On today's show, we're talking data centers, but not just data centers, hyperscale data centers. You don't know what that is? I don't either. I brought in an expert. Stay with the show.
Don't hang up that phone. We've found what you're looking for. Welcome to the Let's Talk Cabling podcast with Chuck Bowser, RCDD. Well, seeing how we're pulling Category 6A, the most powerful twisted pair in the world, you gotta ask yourself this one question. Did I pull 295 or 300 feet? Well, do you feel lucky? Do you, punk? In this podcast, you'll learn the differences between a 66 and 110 punch tool, the proper way to install a support cable, along with testing and certifying the cable. What exactly does RCDD stand for? Registered Communications Distribution Designer. Just the expert you need to ensure your cable plant performs exactly as designed. The elite professional, knowledgeable, and experienced in leading-edge ICT design principles. So join us as we talk about the ever-changing world of telecommunications. From ISP to OSP, from copper to fiber, design to installation. Now, send the new guy to the truck for a bucket of dial tone and the cable stretchers, while you listen to an informative program on telecommunications.
Welcome to the show where we tackle the tough questions submitted by installers, project managers, estimators, IT personnel, and even customers. We are connecting at the human level so that we can connect the world. By the way, if you're watching this show on YouTube, would you mind hitting the subscribe button and the bell button to be notified when new content is being produced? By the way, we just hit 300 subscribers. We are growing. If you're listening to this podcast on iTunes, Google, Amazon, or any one of the other podcast platforms, would you mind leaving us a 5-star rating? If it's not 5-star, get in touch with me. Tell me what I need to do to make this show better. I want it to be good content. If you happen to miss those, don't worry. They're all recorded and put on our webpage at www.letstalkcabling.com, along with our Thursday night, 6 p.m. after hours Ask Chuck Bowser RCD show. They're all there for your convenience. So as I mentioned, today we're talking about hyperscale data centers. And as I mentioned, Chuck knows a lot of things about the industry. Chuck doesn't know everything. And Chuck knows when to call in the expert. So I'm bringing back my favorite guest, Tim Kuhlman. Tim, welcome back to the show. How you doing, buddy?
Doing good, Chuck. Doing good. And by the way, congratulations on your milestone for your subscribers. That's good to hear.
Yeah, it's just growing. I never thought. And the cool thing I like is I'm getting subscribers from all over the earth. I've got Saudi Arabia and Spain and all kinds of stuff, and that's pushing me outside of my comfort box. I like that. I like when it does that. So if you don't mind, just give us the 30-second for those who may be new to the show, since we do have a whole bunch of new subscribers. Just give us the 30-second. Who's Tim Kuhlman and why should I listen to him?
I'm Tim Kuhlman. I work for TEECOM. I'm a licensed electrical engineer, a professional engineer, and I'm basically specialized in telecom and ICT design for the last, 27 years now. And before that, I did construction for telecom while I was in college. So, I think bring is a practical experience of physically installing cabling and conduit and cable tray, and then applying that to engineering facilities.
So you're not just one of them book smart people who just read a book and they can quote all the stuff out of the books. You've actually walked the walk and talked the talk.
I like to think I've made some mistakes and I've learned from those mistakes.
It's funny you mentioned that. I was talking to somebody last night on Low Voltage Nation. They were asking me some questions about estimating, and I was answering them for him. And he's like, "How did you get so smart?" I said, 40 years of learning from my mistakes.
Yeah, a mentor once told me knowledge comes from learning from books. Wisdom comes from making mistakes, and pain is what happens when wisdom rushes in very quickly.
I like that. I'm gonna put that on my TikTok feed. I'm gonna steal that one. So first off, I need you to educate me. What in the heck is a hyperscale data center?
Well, I think we're all familiar with data centers, right? There's computer rooms, there's data centers, and let's start out with the smallest. The computer room is a dedicated space in typically a commercial environment, maybe an educational facility, That has maybe it's 2,500 square feet, maybe up to 20,000 square feet. It has all the servers for the corporation, but it's part of a building. It supports part of an existing facility. Then you have a data center, and a data center, you're looking at maybe it's pretty good size. Maybe we're talking about 5 megawatts, 10 megawatt facility, and it's purpose built to just do data computing. Maybe it's data processing, maybe it's number crunching for research and stuff. And then you get to the hyperscale, and hyperscale data centers are just mega facilities. We're talking where a single building is probably in the 30 megawatt range. It's anywhere from 25 to maybe 35 megawatts. And campuses can be in the 350 to 400 megawatt range. And all these buildings do is computing. So they support the internet. They support anything from cloud storage to social media to probably where this podcast will be hosted. All of that is in the cloud. Well, that cloud resides in hyperscale data centers.
Yeah, it's funny you mentioned it because I say that in class all the time because we talk about enterprise data centers, internet data centers, and co-location data centers. And I use my podcast as a perfect example of an internet data center because when people download my show, they're not downloading it from my computer. I upload my show to I guess it's a hyperscale data center. I never really thought about it, but and then they download it from that show. So tell me, what differentiates a hyperscale from a regular data center?
Well, it's the size, right? And it's just right there in the word. It's a hyperscale. It's the size. So, I mentioned 25 to maybe 35 megawatts for a single building. But we're also looking at, other numbers to consider is, say the average size of a hyperscale data center for a single building is about 180,000 square foot of data center space. Now, that's just what we would call white space for servers. So you're looking anywhere from 5,000 to 6,000 servers. Now, to put that in perspective, a Walmart supercenter is on average about also 185,000 square feet. So think of a Walmart supercenter, wall to wall, with nothing but servers. And then when you start looking at all the back of house support for the data center, the electrical plant could take another third of the space. If you have a mechanical plant, that could take another third. And so depending on how the data center is designed and how it's intended to operate, we're talking about a huge amount of building space. So imagine a campus that has 10 super Walmarts on it. That's a massive campus, massive amounts of power. And the things that we're concerned about, massive amounts of cabling.
Massive amounts of cable. When you said that Walmart supercenter, I immediately thought of my local Walmart supercenter. I just imagine that thing filled with servers. Hey, on or off note, let me ask you a question. It's not related. What's related to data centers and stuff? There's a lot of people out there saying that that when you use white patch panels, that actually helps the data center. They say it helps because it reflects the light better and it doesn't absorb the heat. Do you have any thoughts on that?
Yes, I tell you, back in the early days, back when we were dealing with a company called Secor as opposed to Corning, and they were making fiber optic product, they used to make this really horrible, ugly, off-white patch panel. And then there was a trend in the market where we started going to this black, this austere when it came to patch panels and fiber optic distribution panels and so on. And the thing that I realized back when I was just a technician, I was still doing fiber splicing and polishing, was I couldn't see inside the cabinet anymore. And I couldn't see the labels. There was just not enough lighting in the rooms. And so that was a reality of what happened was we have all these reflective surfaces that weren't reflective anymore because they were all black. And so the truth is, when you do have massive amounts of patch panels and cabinets and they're all black, it takes a lot more lighting. Now, from a heat standpoint, not too sure about that. We use a lot of what we call hot aisle, cold aisle containment type systems so that we isolate the heat on the hot side and then we exhaust that. I'm not sure about the heat issue, but I know from a lighting standpoint, we can decrease the lighting quite a bit if we go to all white surfaces.
Right.
We have a lot more reflectance, and there are manufacturers out there that have been helping us with making white patch panels, white frames and racks, and white coating that we can put on cable trays. So yeah,
Exactly. My day job is that's one of the things they're really pushing right now is the white patch panels. And when you said that, it made perfect sense to me, because if it's everything's black, then the light's not being reflective, and it makes, especially when you start getting older, like me, and you need to see those little labels inside. Quit your laughing. Quit your laughing.
I'm
I
right
know
with
I'm
you.
old.
I'm laughing with you, Chuck.
Oh,
I have the
okay.
same
Not at
issue.
me.
I don't know if I
Okay.
could put on a fiber optic connector anymore.
Exactly.
My eyes.
Exactly. But if it needs more light, because everything's, the racks are black, and the I almost said the LIUs showed my age there. The fiber enclosures are black and everything else. You need to put more lights. More lights generates heat. So I guess it does. Now that kind of brings into the whole environment question, right? So in a regular data center, you could have raised access floors, and you already mentioned the hot and cold out configurations. Would that be the same thing that you can expect from a hyper scale data center?
We would typically not see any type of raised access floor in a hyperscale type data center. I've seen CFD modeling, that computational fluid dynamic modeling that mechanical engineers do. And the results I've seen from that is that a raised floor access system, a raised floor system, is an impediment to airflow. When you get to massive amounts of airflow because of the heat being generated in these facilities, you don't need the raised access floor. It just becomes a restrictive duct. And, folks may want to put cabling under there. And that's what we traditionally did, right? We would traditionally hide all that cabling underneath the raised access floor, and the computer room was kept pretty clean. That's not an issue with the data center. You put all that cabling under the floor, you have two big issues. One, all that cabling is going to be an impediment to airflow. So let's not put the airflow down there in the first place.
Right.
You have to pull up a lot of cable tiles. Well, it's more of a safety issue when you have a really deep access floor to get that much cabling in there. And then, the industry, that it's an obscure thing, but the industry has fought problems with whiskers coming off of galvanized coated tray. The
Whiskers?
electrogalvanized, yeah, zinc whiskers can actually get pushed out of the electroplated coating, and then they just grow. Think of them growing as whiskers over time. And then somebody opens up a tile, moves around down there, and they brush off some of these whiskers, and they get sucked up into the servers. And they're almost instantly vaporized once they get across the set of conductors, but it's enough to probably cause servers to fail and equipment to fail. And then there's
I've
no
never
trace
heard
left
that before. Wow.
Oh, it's an obscure thing. It's not typically a big problem in the hyperscalers, because, like I said, we basically put everything above and not below. And some of that, the cable quantities is driven because the hyperscale data centers typically use a different network topology than what we would see in, say, a commercial type building.
Gotcha. There you go, teaching me new stuff again. Every time I have you on this show, you do that to me. Every time. So let me tell you something you and I've talked about in the past, right? So a hyperscale data center, is that considered a ITE?
Yeah, from a code standpoint?
Yeah.
No, these are purpose-built buildings. No, not at all. I would say, there's some aspects of, say, Article 645 you could apply to a hyperscale data center, but these are purpose-built. And, when you have 180,000 square foot, and so let's just break that down into, say, 4 or 5 data halls of, say, 40,000 or 50,000 square foot, the way you treat that space, the way you may want to provide separation to minimize a risk with rated walls between, groupings of your data centers. Those are things that are just not comprehended from an Article 645 standpoint. And let's not forget, 645 from an ICT standpoint has a lot to do with, I can run non-plenum cable in a plenum space. Well, if I have no raised access floor,
Right.
and that's the only place I can do it, Well, that's moot. Also, when it comes to purpose-built data centers, you're looking at some other drivers out there. For example, Factory Mutual, which we mentioned before, they have directives out there for how to reduce risk in a data center environment. And one of the things that Factory Mutual recommends is to put all plenum cable and all plenum rated communication pathways in a data center. Well, that's just the opposite of what Article 645 allows you to do, which says I can put non-plenum cable in that plenum space under a raised access floor. So I would say that there basically is somewhat separated because of the size and scale of the building.
Gotcha. And I'm glad you pointed out the whole raised floor thing, because my after hours show last night, as a matter of fact, somebody asked me, they're doing work in their first data center with raised floor, and they asked what recommendations did I have for them. And a lot of them had to deal with the floor. Like, and a lot of people don't know this. I'll just pick one of them. I gave them like 5 or 6 tips, but one of them, a lot of people don't realize that almost any technician will know right out of the bat. The tile that you take out of the floor, you better put that same tile back in that same hole in the same orientation.
Yes.
Because if you don't, it's not going to fit right. You'll get gaps, and then air will start coming up through it and cause all kinds of problems. It makes the floor a little bit weaker and stuff like that. So that's pretty cool. So let me ask you this: how is designing a hyperscale data center different from designing a commercial office building?
Well, it's scale. Once again, it's thinking about scale. It's thinking about the cabling. If you were to look at the small, say, higher ed data center, where you got something like 100 cabinets, obviously there's a lot of intense cabling between the networks and the servers. On a hyperscale side, you have hyper problems. You have hyper amount of cabling. And I also mentioned earlier that it's a different type of network. For example, in a commercial building, we're probably still using some type of a spanning tree network where you have a core and distribution and an access layer. Most of the hyperscale data centers are using more of what we call a fabric network, a CLO network, that instead of going all the way up to a core to distribute traffic, say to another server, you literally have switches at a much lower tier level where that traffic can actually talk from server to server. So the amount of intensity of cabling, say from server row to server row, and then from data hall to data hall, and then building to building, can be fairly intense, in that all of these servers are closely networked together in this fabric mesh network at multiple levels, so that they can talk to each other and share that data very quickly. So where we would see in an old spanning tree network, we might see fiber backbone sizes of 144, 288 strands. In a fabric network, it's not uncommon to have fiber strands between the buildings of 1,728. It's a multiple of 288. Or the biggest I've seen is 12 288 bundles of fiber in one fiber cable. So that's a 3456 strands of fiber. And because these are fabric networks, you're talking about maybe anywhere from 2, 4, or 6 of those cables running between each building. And if you got 4 or 5 buildings meshed together, you're talking about a massive amounts of fiber that's just going between buildings. Now, as you go to the different tiers of the network, as you go from, say, where it comes in the building, and then it goes distributed to each data hall and the network center in each data hall, and then each row of racks, it's a massive amount of cabling. So you're also talking about a massive amounts of cable tray. To keep all of that straight, we're looking at multiple levels of tray in a data center to segregate all of that cabling, so it can be managed. I've often said, you put one cable in the ground, you can forget about it, but you put 100 cables in the ground, you got to manage it. Now we're talking about thousands and thousands and thousands of cables in a facility. That's a lot to manage.
What's your thoughts on ribbon fiber, especially for the hyperscale stuff? Because the ribbon fiber, you can get up to what, like 4, 5, 6,000 counts per cable.
Well, I think it's Corning has their rocket ribbon cable. They're one of the ones that are manufacturing 3456 strand cable. That is all ribbon. And so you literally have stacks of ribbon of 24 strands across. And the ribbon cable really works well when you're splicing that to the, let's see, there's two different names out there. The MTP type connector, it's the
an MTP and an
12.
MPO?
Yeah, MPO, MTTP connectors. Yeah, those are 12 and 24 fiber connectors. The ribbon cable really works well with splicing those for pre-terminated assemblies. So yeah, I would say that when it comes to the backbones and the multiple tiers of backbone that we would see in the hyperscale, those are probably all ribbon cables. Gotcha. All ribbon cables.
Yeah, I know that there's a standard for doing data centers, right? The number's slipping me at the moment.
There's a couple out there. TIA has 942.
942, yes, there it is. I almost said 645, and I realized, no, that's code. So yeah, so I know they have the standard for data centers. Is there anything in that standard for hyperscale? And if not, is there a separate standard for hyperscale?
I haven't seen a separate standard for hyperscale. And we should also mention Bixby has their own standard. I think it's number 0002 or something like that. Right. They have a standard out there also for data centers. I think it can be applied to hyperscale. Absolutely. I mean, the concepts, the distribution, the areas that are defined, the BDA, the MDA, the HDA. By the way, no client actually uses that I know of, but those are the terms they have. Right. Those concepts of distribution all work well within a hyperscale data center. It's that, once again, you have to adapt any standard to the hyperscale. So where that you could look at that room of distribution or that hierarchy of rooms applying to, say, one data hall. Well, a hyperscale data center might have 4 or 5 data halls or 6 data halls that they would apply that to.
Gotcha. Now, you and I both love the code, so I got to ask this question. Is there any unique codes or regulations that govern hyperscale data centers?
Not that I'm aware of. We're talking about hyperscale, that is this unique animal compared to commercial, but there's a lot of unique animals out there from a commercial standpoint that, and later on we'll talk about, say, microchip manufacturing. There's another, unique animal. We won't get that in today, but there are codes, there are standards that apply to those occupancies. There isn't anything unique about the hyperscale from an occupancy standpoint. Because of the size, there are some things that you just have to be aware of. A building this large is going to have structural isolation breaks in it. So you have to be able to deal with that. So for tray and conduit movement, because of the size of the building and the nature of the building, the electrical rooms and the battery rooms and the data halls may all be separated with their own fire rated assemblies. So it's not a special code that deals with that. You're just dealing with the existing code and applying that inside the building. We might not see, in a commercial environment, all these different spaces with rated assemblies that you have to pass through. But just because of the size and the nature of this building, we have to deal with it a lot more.
Gotcha. I forgot to ask you earlier, and even though I do the acronym challenge, I still come across acronyms I don't know. What's PUE?
Power utilization efficiency.
Gotcha. Okay. So some of the facilities use free air cooling to bring down that PUE, right?
Yeah.
How does that affect the cable pathway and design?
Well, the biggest impact is probably where the temperature is the hottest. So in a hot L, cold L configuration, we want to keep our cabling, and even on the electrical side, the bus duct on the cold side. But when you're dealing with free air cooling, they design these facilities. These are based on some new ASHRAE standards that came out. I'm guessing they're not that new, maybe about 10 years ago. New ASHRAE standard says that the input air could be as high as 90 degrees coming into these servers. Now, I don't read the ASHRAE standards on a daily basis, so maybe it's 90, 94. I know there is a limit typically on electrical equipment that once you get over 94 degrees and higher, you have to start derating the equipment or the cabling because of the temperature. And so let's just say, for argument's sake, that is the input air to the cold side of your server could be 90 degrees. Well, if you have a delta T 24 degrees across your server, you're talking something that's pretty hot. What, 114 degrees on the hot side? That's pretty darn hot. I mean, for a person just to go in there and do service work, that's going to be very uncomfortable. For cabling, I would say that we would have to really talk to the manufacturers to say, is your cabling designed to be in a 114-degree environment? We know from a copper standpoint that, when we talked about LP cabling, that there are temperature ranges on there, right? On the cabling. Well, we're getting close to some of those temperature ranges. So what we really want to do is be on that cold side. And so when we're looking at coordinating our cable tray and where we're putting the supports and stuff and where those hot out containment walls are going to be, that's what we're coordinating with the architects that and say the electricals that are putting in the bus duct to make sure that we keep our cabling on that cooler side.
Yeah, and if you get cable in that kind of temperature environment, that's going to increase your insertion loss and the performance of the cable way before you're worried about the safety sides of that cable.
Right. So we try to keep everything on the cool side. And I can tell you that, the companies out there that are making product, for data centers like Panduit and Corning, and CommScope, Leviton, those are all guys that they're aware of these temperatures that they're asking their fiber optic connectors to perform in.
Yep. So, I got to go to the design side, especially since I was talking to that estimator last night, although he wasn't estimating a data center. He's estimating something residential. But what are some key takeaways or considerations that an RCD designer has to consider when they're designing a hyperscale data center?
Well, one is, this is not your mom's or your grandma's computer room, right?
I didn't know my grandmother had a computer room.
This is not your old-fashioned computer room. This is a unique animal. So you really need to understand the cabling architecture to support the network architecture. You need to be close with your client to understand the quantity of cables, the point-to-point distribution, so that you have the correct quantity and levels of tray to support all this cabling. Number two is keep in mind that most of the cabling that's going to be put in this data center is going to be pre-terminated. So the thing with pre-terminated cables is you have to have your cable trays as an exact length.
Mm-hmm.
You can't, if it's too short, you can't use that cable. If it's too long, you have this nightmare of what do you deal with the slack? Because it's not the slack of one cable. You're talking about the slack of maybe enough cables to fill a 4x24-inch tray. That can be a massive amount of slack. That can also cripple your cable management. So your distances on your cables for the pre-terminated cables have to be fairly exact. So from a design coordination standpoint, that means once you design that cable tray, it can't move. Let's assume that the distance is not being measured from point to point between your, say, middle of row rack and your network center that's feeding that data hall. That's not being done after everything's constructed, where somebody's pulling a tape and then go ordering, from Corning and getting a cable 6 to 8 weeks later. All that cabling is being designed off of a BIM model. So we're using, a 3D design tool like Revit. Everything's being modeled. Those takeoffs for the pre-terminated cables are coming off the building model, the CAD model that we produce. And you have to make sure that as you coordinate the design for the trays and as you follow through with supporting that design through construction, that you make sure that everybody understands that cable tray has to be where it was designed to be. Because if somebody moves it over 10 feet to, say, miss, I don't know, an air handling duct or something like this, and you added 20 feet of cable, those pre-terminated cables that were pre-ordered may not fit anymore. So
that's a great point, because, I've estimated a lot of pre-terminated fiber before. Not for hyperscales, but usually individual runs or maybe half a dozen runs. And I always went by the rule, it's better to be 10 feet too long than 6 inches too short. Now, with a hyperscale, when you said that, the bell was just ding, 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 ding in my head. If you've got 1,000 equipment racks, what do you do with all those loops, right?
Right. So that's what I'm saying is 10 foot is better than no foot, but really 10 foot could be too much also.
Right. No, absolutely. Now, on the flip side of that, what considerations would an installer have to consider doing a hyperscale data center than a regular data center?
It's the same ones. It's just because of scale, managing all these cables, getting them dressed in so that everything fits, understanding the point-to-point testing. For example, everybody's probably tested a 12-strand 144 or 288 strand. Have you tested a 3456 cable? And have you tested 20 3456 strand cables? Right? Have you done a lot of testing with MPO connectors? And what's critical to test? On one hand, you can talk to the manufacturers and say, well, these are pre-manufactured cables and they're warranted by the manufacturers to be good when they left the factory, and they should be installed by an installer that is certified by the manufacturer to understand how to install their cables properly. But you still have to do a certain amount of testing.
Right.
Another thing to consider is the testing. Maybe some things that are more critical to test than others. When you're dealing with a large ribbon cable, think of this. This is a ribbon cable, and that ribbon cable can bend very easily this way. That ribbon cable cannot bend in this direction. So look at the bundle and work with the manufacturer to find out, if I got a whole bunch of ribbon cable like this all stacked up, what are the most critical fibers to test? What are the fibers in that, say, bundle that is, I sweep this cable around a corner and it gets pulled, placed in a cable tray, or maybe pulled through a conduit? What are the fibers that are most likely to be stressed when they're pulled in? Because those, maybe they get a higher level of testing or get tested early on before you start doing a whole lot of dressing of cables in.
Yeah, a lot of manufacturers are making preterm fiber and stuff, and they usually come from the factory, as you mentioned, pre-terminated and pre-tested. Some of the manufacturers still require that you do 100% testing. Yep. And that's just to make sure that Bubba didn't pull too hard on the cable when he was putting it in the cable tray system. So
yeah,
that kind of brings to my mind, you got to really think about how you manage those test reports in your tester, and will your tester run out of memory room?
Right. Well, when you count up all the fibers, you go, okay, well, it's going to take me X number of long period of time to install this fiber. How long is it going to take to do all the testing? And so it's very possible that you don't test 100% of the fibers. Maybe you start going, looking at more of a statistical analysis where we test, say, just the outer fibers of every 12, or the outer fibers of every 24, or just the outer ribbon fibers of a 864 strand cable. And those are the ones that you actually do the testing on, because if you broke a fiber because you over pulled it, those are the ones that are most likely to break. You still have issues with somebody not having good fiber hygiene and dust getting on the connectors, so that could still crater multiple fibers in one MPO connector at a time. So cleanliness is also something that's extremely important. But I think it's one of those things, when you go into hyperscale, you have to have that conversation that, how are we going to test this? What is the client expecting from a testing standpoint? Is it clearly written in the spec what we're going to test? Because you can't just assume what you've done for a commercial environment is the same that you're going to do for a hyperscale type data center.
I've done quite a few data center projects and stuff. I've never had one customer say, only test the outside strands. They've always wanted every single fiber strand tested and certified. Have you come across any data centers that only requested to certify those the outside strands?
Yes.
Oh, wow. Wow. That's it. That's the second thing you made me learn today.
I can't tell you who, but yes.
We need to stop this now, because my head's already hurting from all the new information you're jamming in there.
The testing is strategic. I can tell you that every fiber is not tested. And that varies, by the way, from client to client.
Oh, absolutely. Absolutely.
And, there's multiple levels of testing, right? There oftentimes we will test fiber when it first shows up to the site, so that, you're not spending hours and tons of labor, pulling in fiber that was bad because it got rolled onto the reel incorrectly from the distributor or from the manufacturer, right? You don't pull in a whole bunch of multi-mode fiber to find out I really ordered single mode and they just put the wrong label on the reel. So there's the typical on the reel testing where you're accepted on site. There might be a post-installation testing after it's got pulled in, and there might be a post-installation testing to verify that every fiber is where it's supposed to be, and that none of the craters got connected. So maybe some of that, maybe every fiber is not tested at every level, just because of cost, or because the risk isn't there, or that there's a cost benefit analysis between what's the cost and time to do all this based on what's the risk that these are actually bad.
Yeah, I could see that, because when you start multiplying, 3, 4, 5,000, 6,000 strands of fiber, cables, multiply them out by, 0.15 for each one that you're testing, that can add up to a lot of labor pretty quickly.
Yeah.
Pretty quickly. Absolutely.
Yeah.
Any parting thoughts on hyperscale? My head's hurting from all this new information that you've given me today.
Hey, it's a big, wonderful world out there. I would say any designer, ICT designer, engineer, or installer that is looking for that next challenge in their career, definitely consider looking out for those hyperscale type companies that are building their networks. They're hiring. I tell you what, we're in a hyperscale building boom at the moment right now as the cloud continues to grow. So whether it's the owner, or whether it's the engineering side, or even on the construction side, I would say that it's a good market out there to be a person that has experience with hyperscales.
Tim, I love having you on the show.
I enjoy being here, Chuck.
You always teach me something new, and you are officially the most person who's been on my show the most as a guest. So, and didn't I talk to you last time about being a member of the expert council? Can't remember if I did or not.
No, I don't think that. I think that's new to me. I'm not.
I think I need to bring you on as one of my expert council. The pay is great. It's $0.
Okay, well, it's just like it is here. Yeah.
Yeah, exactly. And what happens is, from time to time, if I get hit with a question that I don't know, like about hyperscale data centers or something like that, I just kind of reach out to you, and then you just kind of would either just do a short little video, and then I would pop it into the show or something like that.
Yeah.
And, you'd be interested in doing something like that?
Absolutely. It sounds like fun.
Dude, you're on. I don't have to confer with the board of directors. all me. You're on.
Sounds good.
So, I appreciate having you on, and we're gonna have you on again soon. I think the next time we're gonna be talking about chip manufacturing.
There's a chip shortage out there, right?
Yep.
If there's a chip shortage, that means that there are companies out there that need to manufacture more chips. How does that affect the ICT designer and cabling? Right. Yeah, good question.
And it actually affects in many ways, because there's a backlog in test equipment and labeling equipment and stuff that requires chips inside of it. So that's just one way it impacts us, not to mention the other way. So
yep, those are very unique environments.
Yep, we'll definitely have you on. Thanks again for coming on the show today.
Sounds good, Chuck. Have a good day.
All right, bye.
That's it for this episode of today's podcast. We hope you were able to learn something. Make sure to subscribe so you don't miss out on future content. Also, leave a rating so we can help even more people learn about telecommunications. Until next time, be safe.